Thank you, Alex. Thank you, Beth, for your presentation. I can relate to a lot of your kind of sentiments about becoming kind of, I don't know, kind of relaxed in Toastmasters. I think we've all been a little guilty of that, so I really enjoyed hearing that. Okay, so today, as Alex said, I'm going to be talking about how you can turn a cat into a dog using something called CRISPR. Now, I'm going to be honest here. This is the first time I've ever brought notes up to the podium because I'm talking about something I barely understand. I was at a kind of a college reunion with some of my friends, and a really good friend of mine named Emily moved out to Massachusetts and got married, and I met her husband Kevin for the first time. And so I'm trying to be social, you know, he's kind of a strange, nerdy little guy. And he's like, oh, what do you do? He's like, oh, I'm a molecular biologist. Nothing about that. I'm like, so, you know, well, what do you do? I'm like, what's your day like? And he's like, oh, you know, I'm working on how to change cats into dogs. Okay, and I'm like, can you explain? And he's like, well, I'm working on something called CRISPR, which is a way to genetically modify things using a certain technique, which I'm going to try to explain to you today. Now, he went on for about an hour, super excited about this, and I understood 1% of what he said. I really, all I took out of it was the name of the technology, so I could kind of go home, and it's not even technology, go home and research it and see if I could understand it. And so that's what I'm going to try to explain to you today. Now, CRISPR, and this is where I need my notes, stands for Clustered Regularly Interspaced Short Palindromic Repeats. Okay, so not a very descriptive name. However, the name itself comes from the original research in 1980 that was done. In Japan, they found when they were studying the genetic or the genome of certain types of bacteria, they found something that was consistent, but they didn't understand. So these X's represent some of the genes of the DNA that they would expect in the sequence of the bacteria. These areas here that are kind of random looking were anomalies. They didn't understand it. It wasn't something that was part natively of the bacteria, but they found this over and over and over, where they found sequences of expected DNA separated by bits they didn't quite understand. So what they took from that was, well, we don't understand the genome. There's things that we don't know about certain things in nature, and it's just an anomaly. We can't explain it. Fast forward to early 2000, some researchers, now with all of the sequencing that's been done, all of the capabilities for searching genetic databases and stuff, they found when they ran this through those databases, they found that these things actually were exact matches to virus DNA. So it was not the bacteria's DNA, it was actually copies of viruses. And so what they found through research was that these are actually part of the bacteria's immune system. Now, a normal immune response from bacteria, and I think generally, is if a virus comes in, your immune system goes crazy, finds anything that seems different and just tries to annihilate it. But what happens is, over time, your immune system weakens, and if the virus isn't killed, the virus wins, right? So what they found, when a virus invaded a type of bacteria, you can think of these as actually like, a photo, or like a wanted paper with a wanted picture on it, right? So when the immune system of the bacteria goes out, it takes this copy of the DNA and it walks over to this and says, no, not you. Walks over to this. This looks an awful like you. And then if it matches, it basically removes that segment of the DNA from the virus and inactivating the virus. So this is a crucial part of the DNA in a virus that causes it to cause problems. So these little troopers go around with these pictures and they remove that part of the DNA when it finds something that matches that. And then the virus is dead, it's gone. So this is an amazing defense mechanism for bacteria. So now how does this help you turn a cat into a dog? Quickly after they understood this mechanism, it's like nothing they've seen before. It was simple. All you had to have was a string with one segment of DNA and another segment of DNA, and it essentially, an immune response would go to anything that you gave it and remove part of its DNA. So they thought, well, we could use this to change eye color. We could use the same technique, inject someone with it, and these CRISPR things would go out, find the gene that matches eye color, and change it, remove it, or edit it. And so my friend, when he was telling me about this, they actually said with these techniques, you can change the entire genetic structure of almost any organism in several different ways. And so, right now with mice, they're actually able to change the hair color of the mice. They're able to change eye color of the mice, and they've actually are now working on gene therapies to find some of the targeted cancer genes and that sort of stuff, and be able to kind of remove those. So a lot of the genetic disorders that we deal with over time, they can actually test in animals, removing those genes to confirm their analysis of those genes causing the problem. So he kind of went on telling me about this, and I'm just like, and it's almost like he's talking about bits and bugs, right? I don't even understand what a genetic strain is. I don't know what a gene looks like, but it was almost like numbers. He's talking about flipping switches and all this stuff. And then we kind of got into some of the social aspects of it. So there's areas in China now that are studying this kind of in underground labs where they're doing the designer baby thing, right? We've all kind of heard about genetic research to kind of configure the baby exactly like you want. And they actually have done some tests on human embryos that were going to be discarded to actually do this and have some success. So it's a very slippery slope because you can pretty much do anything you want. And one thing that makes this particular technique a little bit scary is that it's cheap. There's other techniques that they've used. One was, he said, called like zinc talons or something that they can use to do similar stuff, but it's very expensive. It's totally, they have to create everything. This is just, they grab this bacteria, they change this, do genetic modification, and they inject it. And it's much, much cheaper, much more accessible. So, my point here today is just, it was interesting for me because I heard this, and I've never really went totally outside of my career and my interest as a programmer to understand and learn something. And when I was reading about this, I found this extremely fascinating, and I was thinking, man, I should have studied some of this in college because this is really pretty amazing stuff. So stepping out of your comfort zone and getting, I wasn't sure if I wanted to speak about this because it's not something I consider myself real knowledgeable about at all, but it was very, very interesting to me. And so CRISPR is here, it's not going away, and it has kind of serious implications in terms of what it can be used for. It can be abused or it can be helpful. It's not here right now if the government is going to start regulating these processes, but there is talk about that. So, anyway, he's convinced that you can change a dog into a cat using this, and you can change a turkey into a chicken. And you can change pretty much anything you want about anything that exists that you know information about genetics. With that, I'll turn it back over to our Toastmaster today.